All right, today we are looking at adding, subtracting, and multiplying radicals, okay? So the difference with multiplying radicals is you don't need like radicals, okay? So if I have square root of 2 times square root of 6, if these were added, I couldn't combine them because they're not like radicals, right? But when they're multiplied, you can combine them because they're both under the square root. I'm going to multiply them together. So really what I have is under my radical 2 times 6, the square root of 2 times 6. Well, we know this 2 times 6 gives us square root of 12, okay? And then from there we would want to simplify our radical, okay? So the things that multiply to equal 12, we know we don't want to use 1, okay? So I'm just going to start with 2 times 6 and 3 times 4. Our greatest perfect square is 4. If you need a list of some of the perfect squares, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 25, 36, 49, 64, 81, and 100. Okay? So our greatest perfect square, these are all our perfect squares, would be 4. Okay, perfect squares are numbers, remember, that you can take the square root of and get a whole number. So we're going to rewrite square root of 12 to be square root of 3 times square root of 4. And we know the square root of 4 is 2. So we get 2, right, in place of the square root of 4, and then we bring down our square root of 3. And this is our simplified answer. So the square root of 2 times the square root of 6 equals 2 square root of 3. Okay. One way you can check your answer is if you were to type square root of 2 times square root of 6 in your calculator, it's going to give you some decimal. And then if you type 2 square root of 3 in your calculator, it's going to give you the same exact decimal. Okay. Let's look at our next example. So since I can't combine 2 square root of 3, right? One's inside of the radical and one's on the outside of the radical. It's the same thing when you multiply. So when you multiply these, I can combine 2 times 3 because they're both outside of the radical. And then I can also combine square root of 3 times square root of 4 because they're both under a radical. It's kind of like if I had 2x times 3x. 2 times 3 would give me 6, and x times x would be x squared, right? You multiply the like parts together. So 2 times 3 gives me 6, and then square root of 3 times square root of 4, 3 times 4 is 12, so we get 6 square root of 12. But once again, we need to multiply our square root, okay? So just like we did square root of 12 here, we need to simplify square root of 12 here. If you've already done it and you now know square root of 12 is 2 square root of 3, and you just want to replace square root of 12 with that, that's fine. I'm going to work it out just because. So things that multiply to give us 12, 2 times 6, and 3 times 4. We know our greatest perfect square is 4, so we get 6 times the square root of 3 times the square root of 4. And we know square root of 4 is 2, so we get 6 times 2 times the square root of 3. And 6 times 2 gives us 12 square root of 3. And that's our answer. Next one, 4 times the number in front, you don't see 1, you know it's just a 1, right? So we just have 4. Square root of 8 times 5 gives us square root of 40. Okay, and to simplify square root of 40, the things that multiply to give me 40. Okay, and that's it. So 2 times 24 times 10, 5 times 8. So our greatest perfect square when looking at our list would be 4. So we're going to use 4 times 10. So we get 4 times the square root of 4 times the square root of 10. And we know square root of 4 simplifies to be 2, so we get 4 times 2 times the square root of 10. And 4 times 2 is 8 square root of 10. Okay. Once again, type them both in, make sure they give you the same decimal. All right, next up, notice you have one term on the outside of a binomial, okay? So like before the example before, we just had one term times one term, right? So you just multiply the two terms together. Here, it says if I had 2 times 3x plus 6, you have to distribute that 2 to both terms, right? Same thing here. We're distributing the 2 square root of 5 to both terms inside of our parentheses, okay? So we'll distribute to our first term first. So 2 square root of 5 times 3 square root of 3. 2 times 3 is 6, okay? 2 times the square root of 5 times the square root of 3 gives us the square root of 15. Okay. And then we're going to distribute to our second term. 2 times 1 gives us 2. And square root of 5 times square root of 6 gives us square root of 30. Okay. So now what we want to do is see if we can simplify either of these radicals to see if we could combine these, if they're like radicals, because now they're being added together. So we want to see if we can combine them. So we get square root of 15. The only things that multiply to give you 15 is just 1 times 15 or 3 times 5. If you looked at the list from earlier, there are not any perfect squares other than 1. So this is already simplified. And then 2 squared root of 3, 2 squared 30. So square root of 30, you have 1 times 30, 2 times 15, 3 times 10, and 5 times 6. So if you go down your list, you will also notice none of these are perfect squares until you get to 1, which means this is already simplified. So this would actually be your answer. Okay. Next example, we have square root of 3 times negative 5 square root of 10 plus square root of 6. So once again, we're distributing. So I'm going to distribute my square root of 3 to this first term. I don't have a number out front in square root of 3, but I have a number here. So 1 times negative 5 gives us a negative 5. And then square root of 3 times square root of 10 is square root of 30. And as we saw up above, square root of 30 cannot be simplified. And square root of 3 times the square root of 6 gives us the square root of 18. We know this can't be simplified, but let's simplify square root of 18. So we have 1 times 18, 2 times 9, and 3 times 6. So our greatest perfect square here is a 9. Okay, so we get negative 5 square root of 30 plus square root of 2 times the square root of 9. And the square root of 9 simplifies to 3. So we get 3 square root of 2. And this is our simplified answer. All right, last example. Okay, so you have a binomial times a binomial. You have the two options that we've learned, okay? I think most people tended to like the box first. I'm doing it extra large. I don't know why, okay? So we would take 2 square root of 3 minus 8 on top and 2 square root of 3 plus 8 on this side, okay? And then you're multiplying them out. The other method is take your first term, distribute it to both other terms in the other parentheses, and then take your second term and distribute it to both as well, okay? Either way, you get the same result, all right? So if we took the box method, we would have 2 times 2 and get 4 square root of 3 times the square root of 3 gives us the square root of 9. Negative 8 times 2 square root of 3, so negative 8 times 2 is a negative 16. Bring over our square root of 3 because we don't have another square root to multiply it by. 2 times the square root of 2 square root of 3 times 8, so we get positive 16. Bring over our square root of 3. Negative 8 times 8 gives us a negative 64. Okay. If you notice right here, these were like terms because they are like radicals, sorry, because they both have a square root of 3 on the end. So negative 16 square root of 3 plus 16 square root of 3, or 16 square root of 3 minus 16 square root of 3, they actually cancel each other out because 16 minus 16 is 0. So we are left with 4 square root of 9 minus 64. But we would want to check our radical to see if it could be simplified. Well, square root of 9, 9 is actually a perfect square. We know the square root of 9. Square root of 9 is 3. So we get 4 times 3 minus 64. 4 times 3 is 12, so 12 minus 64 gives us negative 52. And that's it. If you like the other method better, hang tight while I do that one. If you like box method, then you can end the video. All right, so we would take 2 square root of 3 and distribute it to both terms in the other side of parentheses. So 2 times 2 would give you 4. Square root of 3 times square root of 3 is square root of 9. And then 2 square root of 3 times 8 would give us 16 square root of 3. Negative 8 times 2 square root of 3 would give us a negative 16 square root of 3. And negative 8 times a positive 8 is a negative 64. Okay, and then you're looking at your radicals in the middle here to see that they cancel out. So you get 4 square root of 9 minus 64. And square root of 9 is 3, so 4 times 3 minus 64, which gives us 12 minus 64, which gives us negative, 52.